Question number 15 is entitled, the long one, Conditional Equations, Identities, and no solution. Equations with no solution. For example, if you have x plus 2 is equal to 5, it is not always true that the left side equals the right side. An identity means the left side always equals the right side. For example, if x is 10, 10 plus 2, which is 12, does not equal the other side, which is 5. This is conditional. This here is x is 3. 3 plus 2 is 5. This equation is true under a condition. Under the condition that x is 3. It's called conditional. So I'm going to give you some equations, and you're going to have to state if they're conditional equations, an identity equation, or equation with no solutions. For this one, it is conditional. It's an conditional equation. Why? Because it's only valid, true, under a condition. X must be 3. If I tell you x plus 2 is equal to x plus 2, this is called an identity. Because it's always true. Pick any number for x. Pick 10. Isn't 10 plus 2 equal to, when I say pick 10, I meant for x. Doesn't it equal 10 plus 2? Even if you don't know what 10 plus 2 equals, you know it equals 10 plus 2. 6 is negative 4. Isn't negative 4 plus 2 equal to negative 4 plus 2? It's true for any number. It's true for any value of x. Now, if you try to solve it, you try to bring all the x's to the right side, for example. That if you take away x on the left side, you take away x on the left side. And if you bring in x's to the right side, you have to bring the numbers to the left. So the plus 2, you bring over. And you go, oh, 0 equals, oh, 0. Or 10 equals 10, or 9 equals 9. For example, if you had x plus 2, well, you did have this. If instead all you did was take away x, you just take away x. Well, why then you get positive 2 equals positive 2. That's always true. That's an identity. Once you get the same thing equal, one number equals itself, it's called an identity. If you did it this way down here, you would say identity. It's not conditional, no matter what x you use. For example, x plus x always equals 2x. 5 plus 5 equals 2 times 5. 7 plus 7 equals 2 times 7. This would be an identity equation. It's always true. It is always true. Try a few more. Suppose you have this. This is an identity equation because when you clean up the left side, you get 3x plus 6 minus 1 6 minus 1 is 5. Still equals the right-hand side. This is exactly the same. This and this is exactly the same. But this last line is exactly this line. I didn't add or multiply to it. I just distribute. They're the same. This first box equation is the same as this one, which is the same as the last one. Okay, so this is identity. Now, if you have a number plus 2 is equal to that same number plus 3, I hope you realize this has no solution. You're starting off with the same number, whatever it is, 9, 90, 83, negative 9, pi, the square root of pi, 3.718, negative the square root of 13. If you start off with the same number, here it is. That's the number x. And on the left side, you add 2, so you're now right here. Or you add 3, well, now you're right there. These numbers aren't equal. These two numbers are not equal. They differ by 1. That has no solution. If you did try to perform some legal algebra on this equation, you're going to get an absurdity. You won't get 9 equals 9, you'll get maybe 9 equals 19. Example, if I just take away x from both sides, I get 2 equals 3. This is no solution. If I try to bring the numbers, say, to the right side and x's to the left, I definitely got rid of the x's on the right side. I didn't know I was going to get rid of them on the left. If I'm bringing the x's, if I'm getting rid of the x's on the right side, then I want to get rid of the numbers on the left side. So the left side happens to be 0. The right side, 3 minus 2 is 1. That's absurd. 0 doesn't equal 1. No solution. Whenever you get just one number equals another number, you call it an identity. When you get one number equals a different number, it's no solution. But it can't have variables or letters. One number equals another number, or one number does not equal another number. You got 12x plus 3 is equal to 3x plus 5. Those are both lines, and they have different slopes. Two lines with different slopes will intersect. This is going to be conditional. If I take away 3 x's from both sides, that is, I'm bringing the x's to the left side, so then I want to bring the numbers to the right side. 12x minus 3x is 9x. 5 minus 3 is 2, so 9x is 2. 2 divided by 9 is x. 2 divided by 9 is x. Okay, this is conditional. This top equation is equal under one condition. The condition that x equals 2 over 9. It's conditional. If I tell you x squared is equal to 4, this is conditional. It clearly can't be an identity. When you square a number, you don't always get 4. I mean, 7 squared is not 4. 4 squared is not 4. 8 squared is not 8. It's conditional. The condition is x must be positive 2 or negative 2. It doesn't just have to equal one specific number to be conditional. It can equal 2 numbers, or 14 numbers, or 103 million numbers. It just can't be every number. It can be 103 million different answers. if I said x minus 1 times x minus 2 times x minus 3, all the way up to x minus 1 million equals 0. Well, 1's an answer, because 1 times 1 is 0. And regardless of what these other numbers are, 0 times it is 0. So it's equal to 0 under the condition x is 1. Or x is 2. When x is 2, this will be 0. 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3 is negative 1, etc. But when you multiply a string of numbers, and one of them is 0, the answer is 0. The x will be 1, 2, 3, all the way up to 1 million. There's a million different answers, but it's still an conditional equation. This is conditional equation. What are the conditions? X is 1 or 2 or 3 up to 1 million. So it is not conditional only if there's one answer, or 2 answers, or 3 answers. It just has to be a finite number of them. Even that's not true. Even that's not true. I'll give you an example. Suppose I tell you there's this function f of x, and it equals 7 if x is even, and it equals 13 if x is not even. Okay? So now, I give you the equation f of x minus 7 is 0. Well, this is true under the condition this is 7. Is that always 7? Is f of x always equal to 7? The answer is no. Sometimes it equals 13. F of the square root of 11, which is not an even number. Not 11, but the square root of 11 is not even. This is 13. F of square root of 11 minus 7 is not 0. So this equation is not always 0. Okay? It's conditional. What's the condition? X is equal to 0, even, plus minus 2, plus minus 4, plus minus 6, plus minus 8, forever. There's an infinite number of numbers, but it's not all of them. It's conditional. It's under some condition. It's not always true. So I was thinking it had to be finite. But no, there can be an infinite number of solutions. It's just not all of them. Okay, let's look at these last couple of ones and that'll be it. 7 times, well, what if I said x squared is equal to negative 4? Okay, this has no solution. Because if you square something, forget about the 4 for a moment, can you get a negative? X, there's 3 types of numbers. Negative, positive numbers, the number 0, and a negative. So x is either positive, negative, or 0. If you square a positive, you don't get negative. If you square 0, you don't get negative. If you square a negative, you don't get negative. So it has no solution. Okay. What about this problem? Is this conditional? Is it an identity? Or is it no solution? 21x. The left side has just 21 x's, and so does the right side. This will not be conditional. Either it'll be all solutions, that is identity, or no solution. Plus 7 minus 2. Well, 7 minus 2 is 5. It's an identity. Both sides are identical. It's an identity equation. Both sides are exactly the same. Why am I saying it won't be conditional? Well, both sides I saw had 21 x's. No matter what x is, when you multiply the x by 21, so far they'll be equal. And if you add on the same amount, they'll always be equal. If you add on different amounts, they'll never be equal. Okay. 7x plus 3 is equal to 7x plus 5. These are both exactly the same. No matter what x is, you multiply it by 7. If two of you type in the same number in your calculator and multiply it by 7, you'll get the same answer every time. So far, you have the same answer. You type in the same x value and you multiply it by 7. You're going to have the same answer in your calculator. But then you add 3 and your classmates add 5. It's not equal, ever. It's no solution. If you start off with the same number, whatever x is, 5. 7 times 5 is 35. You both have 35 in your calculator. You add 3, your classmates add 5. They won't be equal anymore. Well, I see 6x and I see 6x. 6x plus 4. Oh, 6x plus 4. They're identical. We call them an identity equation. If you take away 6x from both sides, you will have 4 equals 4. Whenever you have one side being the exact same as the other side, it's an identity. If for some reason, and I don't see why, if you don't see that these are exactly the same, well then when you take away 6 x's, you should see one number equal that same number. That's an identity equation. Okay, this finishes the section entitled Conditional Equations, Identity Equations, and Equations with No Solution. Go over this stuff. It's not bad. Know the definitions for each of them.